Hello ladies, in this video we're going to go through the questions and theory for 10E, which is equations with fractions. Okay, so hopefully by now in your understanding of algebra, you know this first key idea that A over B is the same as A divided by B. So this vinculum, the fraction part, this little line in between your A and B, also means to divide. Now, when we're solving equations, we always think about the opposite sign. So the opposite of dividing is multiplying. So this second point is basically making that. So if we've got a division, so x divided by 5, what we do is to undo that division, or that dividing by 5, is to multiply by 5. And when you think about, well, what that effectively is, and I might just write that over here. So if we had 1/5 and we wanted to get rid of that 5, we just multiply by 5 and we're left with 5 over 5, which is 1. And that's why the 5's disappear. Okay, but whatever we do to the left-hand side, we also have to do to the right-hand side. So you can see here, we've got times 5, and then on the other side, we've also got times 5, so that 4 is multiplied by 5 also. Sometimes in your head you can say, well, what number divided by 5 will give me 4? And that's 20. But other times we get more complicated questions, so that's why we need to solve them algebraically. All right, so the next point is extremely important, because when we're solving algebraic equations, we really need to follow some order. So this first point, it's saying when sorry, I'm just going to read what it says. If neither side of an equation is a fraction, do not multiply by the denominator. So what this means is, on the left-hand side, we've got x over 3 plus 5. The whole thing is not a fraction. We've actually got two terms. We've got a fraction and we've got an integer, or a constant term. Excuse me. So we have to get rid of the 5 first. Okay, so when we're solving algebraic equations, there's always a method of, I guess, undoing. We call it undoing the equation to get the pronumeral by itself, or the variable by itself. So when you've got a constant term, we have to get rid of that first, or eliminate that first. So you can see it says, do not do this, and that's extremely important to remember. Now, there's nothing wrong with doing the multiplication, multiplying both sides by 3 first. You just need to do both terms. Okay, so if you were to multiply by 3, you would have to do both the x over 3 and the 5 by 3. And that just complicates things, and it sounds even complicated while I'm talking, but I'll show you what I mean over here. Might be a bit easier. So if we had x over 3 plus 5 equals 8, your first step is to get rid of that 5, but let's say you wanted to multiply by 3. We've got to hug the whole thing and multiply it by 3. Okay, so that whole side is multiplied by 3. The reason they say do not do this is because people often just multiply this by 3 and forget about the 5. So when you're solving algebraic fractions, do this. Okay, get rid of your constant first. So you can see here, they've taken the 5 away first and left with x over 3 equals 3, and then multiplied by 3. Okay, so undoing the fraction by taking the constant first. All right, the next point is just saying that x over 3 plus 2 and x plus 2 over 3 are different. Okay, so they're just showing how they're different there. So just making sure they're not the same thing. Okay, and you can read through that. All right, so let's do some questions together. So I'm starting at question 1 because, you know, it's always a good idea to do some of the easier ones. I'm not going to do A. Let's do B, and then I'll do C and D. Okay. So we've got 2y over 3 equals 8. All right, so check for any constants first. We don't. We've only got this term. So we don't touch this coefficient of y yet. We just focus on this 3. So let's multiply both sides by 3. Okay, so that 3 cancels out with that 3, and that's how I write it. So I'll just keep my equation there, and I usually write it in a different color. So either use a red pen to show you're working, and then you don't get confused by what was the original equation, what you're doing to change that equation. So we've got 8 times 3, which is 24. And then we've got 2 times y. Don't forget there's a little imaginary multiplier in there. So the opposite of multiplying is dividing. So those 2's then cancel out, and we're left with y equals 12. You can always check your answer by substituting it back in. I'm not going to do that because it's going to make the video very long. But when you think about it, if y was 12, you've got 2 times y, which is 2 times 12, 24. 24 divided by 3. Yes, it equals 8. I know I'm correct. So the good thing about algebra is you can always check your answers. Solving algebraic equations, you can always check your answers through, what's it called? Substitution. There we go. I'll get there. All right, so question C, here we've got a constant. So we don't touch this term just yet. We focus on this constant. So we've got +1, so we want to get rid of it. So we take it away. And whatever we do to one side, we have to do to the other side. So we subtract 1 from both sides first. So we've got 2x over 3 equals then 3 minus 1, which is 2. All right, and I did say I wanted to use a different color, but I didn't really before. So let's do it now. So we've got divided by 3, so we're going to get rid of that first. And when you think of BODMAS, it's kind of like the reverse of that. So, you know, usually we would do our addition last, but we would do that first when we're undoing an algebraic equation. All right, so those 3's cancel out. We've got now 2x equals 2 times 3, which is 6. And let's just scroll. So I did say I was going to use a different color. So let's go back to my pink. And we divide both sides by 2. So then we're left with x equals 3. Now I'm just going to have a look. All right, let's do question D as well. I'm running out of room, but I think I might be able to fit it in just down the end here. I have to write a little bit smaller than what I usually do. 2x minus 1 over 3 equals 5. Now, it's actually good that I'm doing this one, because you might say, well, that 1 is a constant term. Well, it's up here with the 2x minus 1. It's on the numerator. We can't really touch that until we've got rid of this 3. So even though the 1 there is a constant, we can't touch it just yet. We've got to get rid of this 3. It's not on its own. It's kind of attached to this 2x minus 1. So let's get rid of that 3 first. And as I said before, you can always check your answer by through, oh God, I can't talk, substitution. 5 times 3, 15. So, you know, if you're a bit unsure about your working out, at the end, substitute your answer back in, because if you made an error, it'll come up when you substitute it back in. All right, so we've got 2x minus 1 equals 15. Okay, so I've got rid of that 3 on the denominator. And now I want to get rid of this minus 1. So the opposite of subtracting is to adding. So when I add 1, negative 1 plus 1 gives me 0, so they disappear, and I add 1 to this side. So now I've got 2x equals 15 plus 1, which is 16. Now divide both sides by 2. So that disappears, and I'm just going to leave my final answer in red. So x equals 16 over 2, which is 8. Oh my gosh, it feels it's pouring with rain outside. So I was going to go for a walk this morning. I thought, will I get a quick walk in before our lesson, period 1? I don't think I will. Okay, so actually I should check what time our period starts. Just give me a second. All right, it is 9 o'clock. We're starting. I did check this morning on the timetable, but I thought maybe that hadn't been updated. So just had to check my email. Sorry, girls. You wouldn't even know. I paused you the whole time. All right, so let's get on to question 3. So question 3, maybe just a little step further. So let's, I've already written A, so let's do, oops, A, H plus 15 over 12 equals 2. So quite a few questions in question 3A. When you only do half of them, try to do every second question, not the first half, because if you just do the first half, you're effectively just doing half the easy ones, and then because they do get harder, girls, so make sure you do the harder ones as well. And I'm kind of talking instead of explaining what I'm doing. So I'm going to get rid of that 12 on the denominator, so we don't touch this 15 yet. Okay, so we've got to get rid of that 12 first. We only get rid of the constants when they're by themselves. Okay, so then we're left with h plus 15 equals 24. And then subtract 15 from both sides. So that goes, and we're left with h equals 9. Now, again, if you wanted to check your answer, you could do substitution. Okay, it does say check your answers using substitution. So I'll show you what that means with this one here. So if h equals 9, I substitute it back in. So I'm going to have 9 plus 15 over 12. 9 plus 15 is 24. And then 24 over 12 is 2. I know I'm correct. Good job. All right, let's move on to one that's a little bit harder. So I might do, let's do F. It's a bit different to one that we've seen before. I'm writing a bit smaller so I can fit another one on the other side. All right, so here we've got a constant by itself. It's not a part of the fraction, so let's get rid of that number first. So we're going to subtract 14 from both sides. So then we're left with 40 over 9 equals 4. Okay, so 18 minus 14 on that side. Then we get rid of this denominator. So we're going to multiply both sides. Now, if you're ever unsure, just remember this says divided by 9. So the opposite is multiplying by 9. Okay, so they go. Then we're left with 45. 4 times 9 is 36. Oops, I wrote 45. It's a T. Oh my gosh, can't even read my own handwriting. Okay, and then the next step is to divide by 4. It's why it's always important to have neat handwriting, girls. It's a bit harder to write on the computer. But anyway, 36 divided by 4 gives you, what is that, 9 again? Back to 9, are we? And then substitute your answer in. So I can just quickly do that in my head and I could see it was correct. So you can do it in your head, or you can do it by hand as I did with question 8. All right, let's move on. I want to do one where we're working on the other side. So let's look at L. Oh, I don't like when there's Z's because then I get them mixed up with 2's, but anyway. All right, so this time we've kind of got, we're used to having the pronumeral on the left-hand side, but this time it's on the right-hand side, but we do the same thing. But girls, I would usually just rewrite this, and maybe it would be easier for you because we tend to always have the pronumeral on the left-hand side, so you can switch things over. Okay, so whatever's on the right-hand side, you can put on the left-hand side, and then the 12 can go on the other side. And then it looks like everything else. Or you could solve it the other way. It's fine, but putting things, you know, when you're just starting with algebraic equations, it's probably a good idea to put it into something that you're familiar with. All right, so let's get rid of that 10. Remember that 10 is by itself. It's not a part of the fraction, so we get rid of that first. And then we've got 2z over 7 equals 12 minus 10, which is 2. Then multiply both sides by 7. So that cancels out, and then we've got 2z equals 2 times 7, which is 14, so a bit of a longer one. So see what I mean when I was saying sometimes you can do these in your head, sometimes you can't. So one like this you'd need to solve algebraically. So 14 over 2 is 7, and then you can substitute that quickly in. 2 times 7 is 14. 14 divided by 7 is 2. 2 plus 10 is 12. So I know I got that correct. Give yourself another smiley face. All right, question 4. I've just put in because it's talking about negative numbers, so I thought may as well just make sure we're all good with that. So y plus 4 over 3 equals 1. All right, so we've got the 3, we've got no constants other than what's here in the numerator, so let's get rid of this 3 first by multiplying both sides by 3. So we're left with y plus 4 equals 3. And then subtract 4 from both sides. So now that goes, and we're left with y equals 3 minus 4, which is negative 1. Okay, so that's the only difference with question 4. I might do G because it looks a little bit tricky. Okay. Now, as I said before, whatever you have on the right-hand side, you can put on the left-hand side, so you can just switch sides. Okay, so there's nothing wrong with doing that. All right, so the first thing we need to do is get rid of this 5. So let's multiply by both sides by 5. Now, in maths, there's usually more than one way you can do things. So if you're sitting there and thinking, oh, I would have done it, kept it this way, that's fine. And you'll learn as we go through that, you know, there's more than one way to do things. All right, so now I've got 2u minus 3. So let's add 3 to both sides. And we've got negative 2u equals 5 plus 3, which is 8. Now let's just scroll a bit. And then to get rid of the negative 2, divide both sides by negative 2. So that disappears. And then we're left with u equals 8 divided by negative 2 is negative 4. So requiring you to remember your negative numbers for that one. All right, so question 5 I put in because sometimes students have trouble actually writing an equation. So let's go through these. So we're it's got it in words and we need to put it in numbers. So a number is halved. It hasn't told us what that number is. So you can choose any letter you like. I'm going to choose K because it's my initial. It's halved. So when something is halved, it's divided by 2 and the result is 9. So when we solve that, we need to get rid of the 2. So let's multiply both sides by 2 first. And then we're left with K equals 18. All right, I'm going to set up the other ones for you, but you can solve them. Otherwise, we're going to be here for a while. I don't want these videos to get too long. I might just do E and F over here. All right, 1/3 of Q is 14. So 1/3 of Q is Q divided by 3 equals 14. So you can go ahead and solve that. A number R is doubled. So doubles mean we're multiplying it by 2 and then divided by 5. And the result is 3. 3 is added to X. So we're going to have X plus 3. And the result is divided by 4, giving a result of 2. So that's a little bit trickier because we've got the two words result, the word result twice. I missed one, did I? What did I miss? I missed D. Sorry. Let's go back and do D. 4 is subtracted from Q. Sorry. And then halved, giving a result of 3. And then let's get back on track. A number Y is divided by 4. And then 3 is added, giving a result of 5. So there's the equations, and you can go ahead and solve them to see if there's any more. All right, question 6. A group of 5 people go out for dinner and then split the bill evenly. They each pay $31.50. Oh, why am I'm rushing and making mistakes. I don't know why I wrote B. I think because I was reading if B represents. We're doing question A. If B represents the total cost of the bill in dollars, write an equation to describe this situation. All right, so we've got 5 people go out for dinner and then split the bill evenly. So let's say the bill is the total cost. It's split between 5 people. And when it's split between 5 people, they each pay $31.50. So you'd probably know to do that, to find the total bill, you multiply by 5. Yeah? But this is just setting up an algebraic equation. And then B and C, I'm sure you can do. All right, I think that's it. Question 7. Let's have a quick look at this one. Lee and Theo hired a tennis court for a cost of X dollars, which they split evenly out of his own pocket. Lee also bought some tennis balls for $5. Write an expression for the total amount that Lee paid. So we're doing Lee. So he split the cost of the tennis court. So there's 2 of them. So the cost is X divided by 2. And then he paid another $5 for the ball. So that's the expression. Given that Lee paid $11 in total, so if he paid $11 in total, that expression is going to be equal to $11. State how much money Theo paid for his share. So, hold on, let me just think. Okay, write an equation and solve it to find the total cost of hiring the court. So you'd solve for X. And then remember that Theo paid X over 2. So once you get the value of X here, you just get Theo's cost by dividing it by 2 here. So looking at this equation, which I might do with you over here. So subtract 5 from both sides. So then we've got X over 2 equals 11 minus 5, which is 6. And then multiply both sides by 2. So then we're going to have X equals 12. So if X equals 12, that means Theo has paid half of that. So 12 divided by 2. So Theo paid $6 and Lee paid $11. Because remember, he paid $5 more for the balls. All right, guys. Bye.